everybody, and welcome to the Wild Neighbors Speaker Series. We're really happy to have you here today. This webinar is a collaboration with Travis County and the City of Austin, who co-manages the Balcones Canyonlands Preserve, along with a number of other public and private partners. My name is Jeremy Hull. I'm the Community Liaison for Travis County Natural Resources. Today, we are very excited to have Linda Ruiz McCall here with us to talk about Central Texas geology. Linda is an information geologist for the Bureau of Economic Geology. Her experience includes project management and communication with the emphasis on geology, water, and energy resources. Linda leads the Bureau's Texas GeoSign project, which promotes the appreciation of geoheritage sites across the state, and she is committed to helping to build understanding about natural resources. At the end of this presentation, Jai Torres with the City of Austin will be managing a Q&A, so any questions that you have during the presentation, please put them in the Q&A box and not the chat, and we'll be getting to as many of those as possible before the end. There will be a recording of this webinar made and posted to both our Facebook page and YouTube page for a future resource. On that note, I'm going to stop sharing my screen and go ahead and hand it over to Linda.
Thank you, Jeremy and Yaya. And it's a pleasure to be here with kindred spirits of the wild neighbors of the Balcones Canyonland Preserve lands. I was very honored to be asked to speak to you today, and I'm always excited when people are interested in the geology. So thank you very much for letting me join you. Today, I'll be talking to you about Central Texas geology and geoheritage. Now, I work with the Bureau of Economic Geology, and the Bureau has a mission to serve with objective, impactful research in energy, the environment, and the economy to serve society and the public interest. And this is our website. In our role as state survey, we work very hard to provide resources for educators and the public at large, and I'll be focusing on that aspect of the Bureau. Scott Tinker is the director of the Bureau, and he is the Texas State Geologist. I'll also be covering today using many of our geologic maps, and today's talk is an overview. Please, you're welcome to contact me if you have questions, but I want to direct you to many of the images I'll be showing you today are based from the work over many years by our geologists who've done extensive mapping and research across the state, and our Bureau store is where you can find a lot of this information. Here's an example of some of the maps that I'll be covering. And when you go to the Bureau store, at this link, there's a special app to help you find and zero in on the maps. But also feel free to email the Bureau or me or the Bureau manager. We also have many educational resources for the public posted on this webpage, and including a premier radio program called Earth Date that you may have heard on the radio. It has a companion website with much information and PDFs about geoscience. And on this page at the top, to this audience, we recently did a virtual field trip on water resources and innovative water strategies. It's focused here. I'll be showing one of the videos from that work on Mount Bonnell, but there are many other with experts like Brian Hunt and Brian Smith, Bridget Scanlon, and others who have joined in this effort to help understand our very critical needs for water resources in Texas. Today, I just have a few minutes to go over a basic overview of Central Texas geology, and I'll be covering the major events for Central Texas, basically a focus on the surface geology and features that we come in contact with, And also, there was interest in the GeoHeritage GeoSign project, which I'm very happy to share with you today. So let's dive in. This is a picture that shows the geologic map of Texas. And if you look at the colors, those represent the different ages of the rocks, the surface. And we will be focusing in on the area in the red square in central Texas. And if you just look at the broad brush pattern, you'll see that there's some big change going across our part of the state. We focus in a little bit more as we look at these maps. Please note where we see the Colorado River and the impoundments at Lake Travis and the Lake Austin, Ladybird Lake going across the map. Focusing in even more, here's the geology of the Austin area and the Austin West Quadrangle. And now we're getting closer to looking at how the river and the rocks are interacting, which is a big focus of our talk today. I've drawn heavily from the work of others, and I just wanted to make sure you have this citation. This is a map, and along the edges, you'll see a lot of text. I'm drawing heavily from this overview. My esteemed mentor and colleague, Dr. Charles Marsh Woodruff, Jr., Eddie Collins. This is a compilation map of the geology of our region, including the Mansfield Dam, Jollyville, Austin West, and Bee Cave quadrangles. And with cross sections, it's a very rich resource for you if you're interested in the geology of this area. So the Canyonlands. This is part of one of the geology maps that we just referred to. And again, you can see Lake Travis and the Colorado River flowing through the terrain. And notice all these dendritic patterns. The lighter green to the northwest of the map is the Edwards. And then the darker green to the southwest is the Glen Rose limestone. And when we say steeply dissected hill country terrain, I know that the wild neighbors of the Balcones Canyonlands really know what that means. Here you see it in map view. Part of the landscape is sculpted and has remnants, high standing remnants of what was the once continuous Edwards Plateau. And in this image, you can see it looking west from Mount Bonnell, these transmission towers and the flat caps across. Then you also have these rivers and streams just down cutting through the terrain. Another major attribute, of course, is the impounded valley of the Colorado River and its tributaries. And if you look at the pattern of where they're located, they're meandering diagonally from northwest to southeast. The most important water resource in our area is water. Water at the surface at Lake Travis, Lake Austin, and also the groundwater resources, including the Edwards Aquifer that feeds Barton Springs and the Trinity Aquifer that serves many people. And here's an aerial image of Barton Springs. So I'd like to start you off as what we do when we start geologic field trips in this area. We often go to Mount Bonnell, and I'd like to share this video we created featuring Dr. Chalk Woodruff.
Good morning. I'm Chalk Woodruff. I'm a geologist, and I've been in Austin for more than 50 years. I feel amazingly fortunate to work in this area. I'm standing right now near the crest of Mount Bonnell, which overlooks the Balcones Escarpment, which is a major geologic break in the land here that separates two of the grand geographic provinces of North America. The Great Plains stretches west of here, and the Gulf Coastal Plain is extended east. And we're right on the boundary. This is also the boundary, the beginning of the American West, where you have arable land, you have farmland on the Blackland Prairies out here to the east, and you have rangeland, grazing animals out here to the west. It's not farmland anymore, it's rangeland. Right here, we're overlooking the Mount Bonnell Fault, which is the main line of displacement in the Balcones Fault Zone in Austin. It has a displacement of about 600 feet here, and it runs northeast-southwest. We're looking southwest here across the lake, across that little meander bend, and onto land again near that blocky brick building, which is the intake for the Ulrich water treatment plant. The fault has displaced the more ancient lower Cretaceous rocks here up against the down-faulted younger rocks. And that fault is responsible for the creation of the Balcones Escarpment. One of the attributes of the Balcones Escarpment is that it's a significant weather maker. It's the first significant topographic rise inland from the Gulf of Mexico. So these unstable water-laden air masses move inland from the Gulf and hit the escarpment, where the topography causes the air mass to rise and become more unstable, and these incredible rainfall events occur. The Balcones Escarpment region has been noted as the locus of greatest flood-producing storms in the lower 48 states. And so a danger exists. It's a climatic hazard. Here we are looking west of the escarpment, looking towards the remnants of the Edwards Plateau and the hill country. The plateau stands up as a flat horizon. That's the Jollyville Plateau, which is an outlier of the more continuous Edwards Plateau. Similarly, across the lake here, across the Colorado River, Lake Austin, you have these caps of hills that those transmission towers are standing on, and those too are remnant pieces of the Jollyville Plateau, the Edwards Plateau, that has been cut away by surface erosion. And you have these steep, high gradient streams coming down to the lake, and those too are sites of danger from flash flooding during these incredibly large rainfall events.
So to continue and just emphasize what Dr. Woodruff was talking about, in Central Texas, we are on a major boundary between two physiographic regions, the Great Plains, which stretches to the west of Austin, and the Gulf Coastal Plain to the east. And on this map, you can see where Austin is located, and along this line that on the map represents the Balcones Escarpment. The hill country is just west of us, then the Edwards Plateau, all part of the Great Plains. And to the east of us, the Blackland Prairies, that very rich farmland and rangeland of the Gulf Coastal Plains. So for the geology of Central Texas, we live on a major physiographic boundary. If you look at the topography, and I apologize, this is just to give you an overview, you can see the dark lines that are so close together on those topographic intervals, which are roughly 20 feet. The dark parts show how steep the land is. And this is, again, the incision by the rivers that is going across that the Balcones Edwards Aquifer, Edwards Plateau. So you can see even from this view that we have this incision going on. If you look further from space, this Landsat image from 1976 shows the Balcones Escarpment very clearly. Here we have Austin on the northern side of this map, northeastern, and then San Antonio. If you look, this redder version is capturing, in the false color infrared, is capturing the oak juniper uplands, marking the southern margins of the Great Plains, and versus to the east, the coastal plains. So you can see the expression of the Balcones escarpment from space. The Balcones fault zone, and here again, we're looking at the local geology of Austin. Here's Lake Travis in the Colorado. These colors are the geology, the geologic age. You'll see these lineations going through, which represent faults. They're down to the east faults, and across the width of 32 kilometers, we have a fault zone that goes across central Texas, the Balcones fault zone. Now, Mount Bonnell is a major fault in the Balcones fault zone. And in this diagram, you can see that here we show the Mount Bonnell fault, and there's actually 600 feet of displacement where the fault is down to the east and up on the west side. The Mount Bonnell, a lot of people think it's the highest point in Austin. It's not. Mount Barker is. But by looking at the rocks, at the geology, we're able to determine how much movement has happened across this fault zone. The question is, in geology, sometimes people think it's just rocks, but really the underlying reason why we study geology is to understand the geologic history. How did we get this landscape? What sculpted the terrain? In Austin, at the surface, we are mostly in rocks that are of Cretaceous age, between 66 and 100 million years old, during a time when all of central Texas was covered with ocean water. There were variable marine conditions, some change in depth, temperature, salinity. We had some sands and oozy limestones and clays, eventually hardening into the bedrock that we know. And some of the formations that we've highlighted are the Edwards limestone and the Glen Rose limestone that are so prominent across the Balcones Canyonlands. The next major event in the geologic history of our areas has to do with the displacement. The Mount Bonnell fault and Balcones faulting happened about 15 to 20 million years ago, where there was a movement so that the rocks broke downstepping to the east. And that created this big division across the state in that period of time. Now, with that structural change and displacement, it affected the flow of rivers. And some rivers actually combined their flow and changed the direction of their flow, so that the role of erosion in sculpting our landscape by the Colorado River and its tributaries around the time of this faulting 15 million years ago move across the Edwards Plateau, and which was once an unbroken set of rocks across central Texas. With the faulting, there was aggressive downcutting by the Colorado River, and the stream sculpted the landscape, leaving these isolated remnants of the Edwards Plateau and forming the Balcones escarpment. So the story of the Canyonlands is basically captured here in what we see at the surface. It's the deposition of these rocks that happened more like 100 million years ago and solidified. It's the uplift and faulting that occurred 15 to 20 million years, and then the continuous process of erosion and downcutting that sculpts the land and creates what we see in the landscape of the Canyonlands. So one of the things I wanted to share with you, besides this overview of the geology, is that we have been working to reach out to the public and share about the geologic heritage. We have a Texas GeoSign at Mount Bonnell, and this is Chuck Woodruff and our artist and colleague Francine Mastrangelo. And we partnered with the city of Austin to be able to share this information while people are out in parks and interested in it. And you can see this at the top of Mount Bonnell over if you go to the southern edge by the picnic table, which I think many of you probably know. You may see our new Texas GeoSign. Now, the primary mission of our Texas GeoSign program is to engage and educate the public when they're about the geologic history, when they're out visiting parks, rest areas, and other public locations. We have several of them in place and hope to continue to build this network. This is a map of some of the locations. But as we began this work back in 2016, we were connected with this broader group. It's really national and international about geoheritage. And that is a term which is really getting some momentum, that to identify these very special sites that have scientific, educational, cultural, or aesthetic value. And the link below is to the Geologic Society of America position statement on geoheritage that would give you more information. So we realized what we were doing in our geoscience program really is part of this geoheritage movement. Geoheritage sites serve the public interest. They're resources for the public. These sites can be used for scientific studies, outdoor classrooms, enhancing the public understanding of science, recreational use, and also economic support to communities that really want to highlight and build tourism at these sites. We currently have Mount Bonnell is designated as a geoheritage site because it has many of these attributes, being one that has the scientific, educational, aesthetic, tourism value. This is one that has been widely accepted to reach that level of a geoheritage site. But currently, we're working in partnership with Texas Parks and Wildlife and hope to have a geoheritage site, GeoSign, soon at the Pedernales Falls Park, Enchanted Rock, and other sites. And you can see the signs we've completed at our Texas GeoSigns website. You can download the signs if you're not able to visit the site. The content is freely available, and we welcome this and hope that that will help promote the education and interest in these very special natural resources that we have. You know, just to summarize, it's our intent, and we depend on collaborative partners like the wild neighbors to increase the awareness and build motivation for the public to conserve these very special geoheritage sites. So with that, I would like to invite you to go to this link and share your ideas. If you would like to suggest sites for geoheritage recognition, we're currently working on a project with the U.S. Geological Survey to just map the sites, to identify the areas that have the scientific, educational, aesthetic, cultural value. If you'd like to submit them, we'd welcome that, or just contact me. I want to thank you. Here's my contact information. And with that, I will just end and see if people have questions.
Thanks so much. So I am going to put a couple of links in the chat, some resources. So
Now let's see anyway.
right, and so we've got some resources that link to the Balcones Canyonlands Preserve, City of Austin's BCP ArcGIS story. We have the Balcones Canyonlands Preserve events calendar in there, so you can see events going on across the BCP with multiple partners. We also have an interactive map of the BCP that you can check out. And we've also added some new links for this presentation. So the Bureau of Economic Geology's homepage, State Geological Survey information, and more information about the Texas GeoSign project. So those are all in the chat. And I'm gonna go ahead and move over to Q&A. So the first question we have, someone is asking where they can find information on radon and aquifers, such as the Hickory and Ellenberger San Saba aquifers.
Oh, that's a good question. And I'm not sure, can you stop my sharing? I think I'm going a little off here. I lost my tab. I hope you're not seeing my screen right now. I'm moving around. Okay. I'm not sure why I can't see the Zoom, but yes, for the water quality and information about aquifers like the Hickory, I highly recommend going to the Texas Water Development Board, their groundwater section. They have information there and many published reports. They look at both at the natural causes of constituents of concern, and also so the Water Development Board, I know, has published information and reports on the Hickory and what's naturally occurring. And there are naturally occurring radioactive elements in some of the aquifers. For any contaminants that falls in water quality, that would be the Texas Commission on Environmental Quality.
Awesome, thank you.
Mm-hmm.
So the next question asks, are there any downloadable GIS layers of the type of geology maps that you were showing that the public has access to? And if so, where can I find those?
Yes, and we have a, let's see if I can share that. That's something that we're about to release a new set of information for. Let me put it in chat. At the Bureau, we have a mapping section, and they have published some GIS information for the maps. And let me see, mapping. So I'm going to put in the chat a link where you can get more information on that.
Great, thank you.
Mm-hmm. There you go.
All right, so next question, are these signs for public land only? I'm wondering about bluffs above Leander dinosaur tracks. Even though it has many visitors each year, it's on private land.
Oh, that's a great question. Well, it's actually the signs themselves, we are targeting publicly available locations because our main goal is to educate the public. So that's one of the things that we basically have as a requirement, that it's publicly accessible. But geoheritage and identifying those, there are often locations that may be on private property that we would want to build into our inventory for conservation purposes, but not necessarily broadcast that to the public, because there, for instance, what if it's a fossil location, like the trace fossils of dinosaur footprints, but there are others. There are some existing in caves which have data basically recorded of things that might help us understand changes in the climate or evolution in these areas that need to be pristine for sampling. So we will be very careful. And yes, there will be some private properties that we would like to include just to document the scientific value of those locations, but we would not share that out and make it public.
Great, thank you. Next question asks, what are some of your favorite easily accessible road cuts that show some great geology around Austin?
Oh, that's a good one. You know, there are many, and let's see, I'm going to share a link to the Bureau store. We have many geologic guidebooks, field guides that the Austin Geological Society has created. And okay, this thing about road cuts is that, you know, over 90% of the land in Texas is privately owned. So road cuts and the accessibility to seeing the rocks is kind of limited, and that is why road cuts feature so prominently. You can actually see the rocks and access them. The ones in the Austin area, of course, along 360, you have great exposures of the Edwards and the Glen Rose that we see as you're driving on 360 across the Pennybacker Bridge. You can see them as you head out west towards Junction. When you go out to the Llano area, getting a little farther west, but I direct you to the Austin Geological Survey. And again, we have many of their guidebooks. Again, I will say the store, I didn't mention that we are not for profit. So we just offer those guidebooks as a cost recovery to just cover the print costs. Another resource we have, just going a little broader from the Austin area, is a publication called Texas Through Time. And that is a very comprehensive publication about the geologic history of the state. Now, part of that included the great places to see geology in the state. And we published a smaller booklet called The Great Places to See Texas Geology. And that is, all public places across the state where you can see the geology and get an understanding of what's significant.
Awesome. All right, so next question. Can you talk briefly about the unique geological features in the Balcones Canyonlands and Central Texas area, i.e. karstic limestone, fossils that can be found, that sort of thing?
Oh, yes. Well, a bit. You know, the karst development in the Balcones Fault Zone is extensive, and I'm sure the person asking the question can know. One of the trips I've done in conjunction with the city of Austin with the public is to take a hike along Barton Creek to look at Airman's Cave. But there are many, many caves developed. So you know, if you think about limestone, which mostly is this calcium carbonate, and the impact of water that interacts with it and can dissolve out and create these caves, are the Balcones Fault Zone area, the uplift and the faulting creates conduits for water to work on that limestone. So there are many, many caves developed here in our area and then there's several that have public access. I mean, Inner Space Caverns is one nearby that many people can visit, but there's smaller caves all throughout the Balcones Fault Zone. As far as the fossils, they're key. I was thinking about and talking with my colleague Chalk Woodruff about how difficult it is to just look at a hand sample that somebody collected of limestone and they go, oh, what is this? You know it's a limestone, but it's the fossils in that rock that help geologists really identify which geologic formation it comes from. Other characteristics too, but a long-standing method that geologists have used to identify formations has to do with the paleontology, with the fossils. And the University of Texas has an amazing collection at our non-vertebrate paleontology lab of different examples of fossils. If you look at the Edwards, it's very famous for rudist reefs. It was a time before coral that we know in modern times were really forming reef. These rudists were like oyster creatures that created pockets of reefs, and they were the reef-forming organisms. The Glen Rose formation, a lot of that is identified with many, many different kinds of echinoderms and pelecypods. It's a wide variation. Some of the formations are just in a period of time where there's a lot of reef building. So you'll hit pockets where there's a lot of fossils. Others, the environment may have been a little deeper. So you mostly get just this kind of fallout of the smaller plankton shells that gather like ooze. So the fossils are distributed. If you think about modern day Florida, for instance, you're thinking of paleo environments when you cross these rocks. You may walk across what used to be a reef, or you may come across something that may have been like a shallow shoal or a lagoon. So the distribution of fossils is going to vary. It'll vary geographically, and then also varies vertically across geologic time as shorelines slightly change through millions of years.
All right, great, thank you. So I'm going to ask, do you mind resending that link to access the GIS layers into the chat again?
Okay. Let me see. Okay.
See if we get it.
Oh, I think I sent it just to one person instead of everyone. Here we go.
Okay, great. Yes, I can see it now. Thank you. All right, so the next question is there a geomarker at the Blund Creek Nature Preserve in Austin?
Oh, I'm thinking is that question about a geologic sign?
Yeah, I think, but yes, I think they're asking about, yeah, geomarker or a geologic sign.
So that's a really good question because, we started this Texas GeoSign program at the Bureau in 2016, but there are many signs across the state that have been done in collaborative efforts with geologists and other partners. And I do believe Blund has a geologic sign. One of the things I'll be doing is to try to draw these into our network to help people find those. But yes, we have many signs, and it makes sense. People, when they're out in nature, of course, they're looking at all the beautiful living environment, what they see in nature, and that's when their curiosity about the rocks comes up, like in the landscape. So yes, I believe there are geologic signs there. We don't have them posted on our GeoSign project because they were not developed by the state survey, but I hope that we can incorporate links over to those resources soon. Thank you.
Okay, and so on a similar GeoSign project topic, are you also partnering with federal public partners for that project?
Yes, yeah, the Geoheritage movement, for instance, Big Bend National Park would be an example. And again, they have several locations with their signs on the geology, but to identify geoheritage sites, the National Park Service has been a real leader on that. So we would look at national, state, local, community areas and partners in order to identify these geoheritage sites. Yes.
Great, thank you. And I know you guys have, the Bureau of Economic Geology has some job opportunities open, but do you all offer any internships that you know of?
Yes, and that's something that if you send me an email asking about that, it varies on what's available. You know, we do work really hard to support students because the Bureau is part of the University of Texas. So we have many students that work with us, and I'll be happy to forward that information over to Human Resources to see if there's any opportunities now.
Great, thank you. So next question is asking, how were the faults associated with the Balcones fault zone formed?
Well, in the fault zone, what's happening is that there's this regional stress that basically is for these types of faults in the Balcones fault zone kind of stretching the land, and the breaks in that or the faults, it's not like there's just one fault. There can be a series of little breaks down dropping to the east that creates this fault zone. The end result is the change in elevation so that it's up thrown to the west and down thrown to the east. But a zone of faults means that that stress is distributed across many breaks. Some of them are major, like 600 feet of displacement along the Balcones fault, about Mount Bonnell fault. But there are other major faults. Then there can be many small faults. I get calls all the time, like I have a fault, or you'll see 5 feet of change or 10 feet of change, but 600 feet of change is a major fault. So it's related to the fault zone is related to the same regional stresses that make this displacement in the earth. And the faults are just the expression of it.
Okay, thank you. Another question, where in and around Mason do you recommend looking for unique rocks?
Oh, there's just been a new geologic map. So if you go to the geologic map links, please look at that or contact me or the Bureau store, and we can let you know that is such a cool area, and there's some new publications on that would help you find that information.
Thanks. And someone is asking, if there's a resource that you can find information about radon and prevention of radon in homes, or mitigation, particularly in the Llano uplift region or west of Burnett, or slightly southwest of Lampasas.
Yes, on this area of the radon, and I would say the Texas Commission on Environmental Quality, or EPA, might be good resources for assistance.
Thank you. So someone is asking, is obsidian commonly found in this area?
Well, that's a interesting question, and I'll have to say not common in this area. But there were volcanoes in this time of the Cretaceous, and Austin actually has one east of us at Pilot Knob. There were a whole series of volcanoes just basically trending along the Balcones Fault zone, but it was before Balcones faulting. There's some, down in along that trend, Mount Inge, near Uvalde is another one that's a state park that's actually a volcano, and they were basalt. So you can find basalt, not as much of the obsidian, which is from a volcano, but obsidian is really that magma that cooled so quickly it created glass. But we have a lot of basalt, which cooled as lava flowed to the surface, very high content of iron, magnesium. So they're like almost black rocks. And you see them, they're being quarried. Vulcan is one of the companies that quarries it, and you'll see them along railroad tracks. You can see them in Austin, that black rock cobbles that are used on railroads, those are parts of volcanoes that were here in Texas 80 million years ago or so.
Awesome, thank you. Another question, there are some very interesting spherical and tubular red stone formations, likely iron concretions in the Bastrop County. Do you know of any resources for learning more about these kind of formations?
Yes. Again, if you contact me, there's different publications on that. It's very interesting on the chemistry of how concretions form and where they form. We have many in Texas, especially along the Gulf Coastal Plain. When you get into those sand, silt, and clay type formations, fluids are flowing through the rocks and bringing dissolved constituents that can precipitate out and form cements. Sometimes they'll nucleate around a center. Sometimes they grow around something and work towards a center. But if you send me an email, I'll see if I can give you some references to some work that's done on concretions.
Great, thank you. And do you know if there is a geological map that has a road map overlay so that we can get a better appreciation of where the faults and other features are located more closely?
Yes. Well, we have one on a statewide level that is a Texas Geologic Highway map that we offer through the Bureau store. And then many of our, well, I'll tell you what, I will share a link. The U.S. Geological Survey has the National Geologic Map Database that we cooperate with. And there's a feature called Map View there, where you can see the geology, and then there's a layer where you can control the opacity of the geology and see the underlying roads, which I really love to use if you're working online. Many of our maps will also have the major highways and roads posted on, as well as the topography. So it does vary, and I will share that map view link with you. It may take me a few minutes to put it in the chat, or I can share it with Jaya afterwards.
Great, thank you. And next question's pretty interesting. Can we briefly discuss the history of why Enchanted Rock is a giant granite dome?
Oh, yes. Well, very briefly, and I want to shortcut it. There's a lot of interest, of course, in Enchanted Rock. What I talked about today was the surface geology, but the Enchanted Rock is a granite, and granites were magma, molten rock, but they didn't solidify and turn into rocks at the surface the way the basalt or obsidian we were talking about do. This was magma that solidified way below the surface, 10 kilometers, 5 kilometers before the surface, and we call that the basement rock. To have this circular outcrop, a dome of the basement rock come up in the middle of Texas is a really amazing feature of the geology of our state. You have to go practically to Canada to see rocks like that, the basement rocks coming out, unless there's mountain building. So there's a lot of discussion on why that occurred, when it occurred, and giving a brief overview of it is difficult, but there was an uplifting of this, and then the erosion around it uncovered that basement rock that we see at Enchanted Rock. Is kind of a very short description of why it's there.
Great, thank you. And someone else is asking, will or do the geosigns have an interactive component?
We have a website, and for that's something that we want to continue building out as far as additional information. I'm not sure about the ideas on making it interactive, but I'd welcome it if there's ideas of how to make it so. We've translated one of the signs into Spanish. We are trying our best to reach out and help people to engage them on this. So I'd welcome ideas on how to do that. But we have a website, we have PDFs that are downloadable, and we're adding other information to try to broaden that reach.
Okay, thank you. What advice would you give to an older person looking to get involved or work in the geology field? Are there technician courses you recommend, other certifications?
Well, being there, to work in geosciences, it's such a broad area of the land, the water, the air, all of Earth's systems. It really depends on your area of interest. I mean, it involves many, like at the Bureau of Economic Geology, we have many different positions where people are working in geoscience, but they may be helping us to be field technicians. They may be working in warehouses with our core repository. They could be working in administrative functions supporting our geoscience efforts. It really takes a team. Now, of course, the universities offer training in geosciences, but there probably are many other options that you can go to. If locally, Austin Community College, Texas State, there's other universities, and dare I say Texas A&M, that offer training in geosciences. Again, if you're interested, contact me. I'll try to put you in touch with resources. We are also often hiring for research work, though often that does involve having a PhD level in science, but that's not the only level of education needed to contribute to geoscience. We depend on educators to help us, and so you could work as a teacher in earth science, which I have done before, and there's a great need for that. And the informal educators, such as the programs of the Wild Neighbors and what you're doing with this program, are amazingly effective in helping to build awareness of the geologic and natural resources.
Wonderful, thank you. And I think we got about 2 minutes. So one last question. This person has noticed conical hills near lakes in the area. I think even one visible from trails at Warbler Vista in the Balcones Canyonlands National Wildlife Refuge. Are they related to volcanic activity or something else?
There are these kind of spiky looking hills in the terrain, and unless I look at the map for sure, but when we talked about these outliers, some of the Edwards can be very resistant to erosion. So there'll be cap rocks that will be present when everything else erodes around it. So it creates these little hills, or others wouldn't call it mountains. We call them mountains in Texas, but they'll create a kind of a rugged terrain. And often you'll see little caps of resistant Edwards overlying the less resistant beds of the Glen Rose. That's what I'm guessing you might be seeing.
All right, well, that was the last of our questions. Thank you so much, Linda, for a wonderful presentation. And thanks everyone for all of your great questions. And we will go ahead and wrap it up.
Thank you very much. And I appreciate all the great questions. Appreciate it. You guys have a nice weekend. Thank you.